Hey folks, so in this video I want to do another example of using the Fantastic Four to solve a recursive problem. So what are we going to do here? We're going to start with the first four steps that we kind of talked through, right? We have kind of these four things to do, right? And then we can get enough kind of knowledge about a problem that we can actually write the code for it. So here we're going to be looking at is basically computing the nth Fibonacci number. So let's see. And I want you basically to do, as we go through these, ask yourself what should you do? All right, so step one, formulate the n-size problem. What do you guys think the size n problem is? Well, basically to solve the Fibonacci of an nth number. So it's like, well, I need Fibonacci of n. That means I need to have a method called fib, right? I can call it Fibonacci, whatever. And this thing will have basically, one argument, which is n, right? So this is, pretty straightforward. You may or may not have this bit at the end. So this is long. Basically, that's the return type. I'm going to assume that Fibonacci numbers can be very, very large. So I'm going to use a large variable to kind of store, more of those possible values. So yeah. All right, so I have long fib int n. So this is my whole size problem. Take a Fibonacci of the nth, to find the value of the nth Fibonacci number. Let's see. What about stopping initially and corresponding values? What do you guys think should be that? All right. Well, in that case, it basically comes from like the definition of Fibonacci. It's really simple. If we're looking at the 0th one or the first one, return 0 and 1 respectively. Okay. And this, right, depending basically on where you're starting the sequence, these might look a little bit different. But this is, the kind of the most standard one. So yeah, not so bad. Next thing we want to look at doing basically is finding that subproblem. So a subproblem here is basically going to be, well, okay, you guys are supposed to be doing this. What do you guys think the subproblem will look like? So a subproblem basically looks like doing fib on a smaller number. So we want to do fib of n minus 1 and then fib on n minus 2. So it's a little bit more complicated than something like factorial because now we need two previous results instead of just one. And that's actually the reason why we have two base cases. So over here, right, it's like, well, if I call, for example, fib of, let's see, do fib of 2, right? Fib of 2 requires me to have, fib of 1 as well as fib of 0. It's a really bad 0, but I need to have two different results, right? And so because of that, right, because I have multiple recursive calls, when I'm solving the problem, I need to have, multiple base cases for them to hit. So I need to have two of those there. All right, so the last question there is, how do I construct a solution of the size n problem from the size n problems? Right? How do I combine the two subproblems, maybe a little bit of work and get the whole thing? What do you guys think? All right, I've actually kind of spoiled it here. It's really just this, right? So if I want to get the size n number for the Fibonacci, basically what I do is I add in the size n minus 1 as well as the size n minus 2, right? So these two subproblems, I just sum them together. And this gets me the whole thing. So not bad, not bad. So here we go. This is kind of the full code here. So we have basically our Fibonacci, right? And we have our two base cases for 0 and 1, and then we have our recursion, right, which is two calls here. So it's pretty straightforward. Now this is okay. So this is deceptively simple, right? Factorial is simple as well. You may think that basically recursion is really simple and also not that useful. That's wrong. So this, and I'm going to bold this here. But as kind of a general note, right? Recursion is very useful whenever you are faced with a problem you do not know how to solve. Okay, this is a rule of rules. Okay, due to the structure of our world, and this could be a whole other class, right? But due to the structure of our world, things are kind of naturally recursive, and so if I am looking at something that I don't understand, what I can start with doing is looking for some sort of recursive structure, because typically that's what I'm going to find. That's how the world is built, right? That's how that's how things kind of naturally are, right? It's like, well, to me, one of the examples I like thinking about sometimes is things like, so I have a background in biology and chemistry. I think about like polymers in chemistry. It's like, well, I have something built from something built by something built from something built from something. It's the same thing, repetitive thing over and over and over again, right? That's how plastics look. That's a recursive structure, okay? Recursion is basically a fundamental technique, right? For building larger things from smaller things, okay? So in general, if I'm looking at a problem I don't know, a lot of times it just so happens to be that it is something that I can rephrase in terms of recursion, because just so many things in our world have this natural recursive substructure behind them, okay? So it's always, at least for me, I consider it always a good approach to start with recursion. Typically what you want to do is, if you're not sure how to solve a problem, you start by trying to solve with recursion, and then, right, once you do it, then maybe you can do some optimizing, maybe then you go back to normal loops, do something else. But typically, right, your first shot should be with recursion because it's the most natural fit for most problems. It'll be the easiest way for you to solve it. All right, so in this video, right, we've done a little bit of an example of Fibonacci, which is rather simple and straightforward, but also, we have my little rant here about why recursion is nice. Hopefully now you have an even better sense of what recursion is like.